Hi everyone, my name is Neesa.
And I'm Norazila.
My name is Ila&Mimi. And I, Daie. We are from
L02.
Nothing in this world.
No one remember my birthday.
Daie, happy birthday!
Yay!
Happy birthday to you. Happy birthday to you.
Daie, I got balloon for you.
Yay!
No!
Three.
My balloon. Daie, don't cry.
Daie, look here. There's a balloon. OMG.
Why the balloon does not burst?
Let's go and ask Madam Army.
Yay!
They
Okay, let's go just direct to our objective. Okay, heat conduction is defined as the transfer of internal energy by microscopic diffusion and collision of particle and also or the quasi-particle, which is quasi-particle is defined as the acetone or phonons, or which is the elements that does not which is interact with the elementary element and exists as the free atom. And these two particles, which is the collision of the particle, is within a body due to the temperature gradient. So basically, heat conduction is based on the Fourier's law, which is it states that the rate of heat flow will be directly proportional to the area normal, to the direction of flow area, to the negative rate of temperature change, and also with the distance of direction flow, which is the rate of flow, heat flow will increase, and as well as the area normal, direction, and so on. So yes, Neesa.
Madam, can you explain it in the example because I couldn't understand the definition.
Okay, good question. Okay, let me ask you again. What is the common application of heat conduction in our daily life? Can you give me one example?
Madam, how about the balloon that we fill with water and the balloon that is without the water?
Yes, good example. Okay, I will explain about that. Okay. About the balloon with the water and also the balloon without the water is actually the most common heat conduction which is applied in our daily life. Which is okay, we have the two balloons. Okay, the first one is without the water, and the second one is with the water. Okay. As for the theory one, previous research has stated that the balloon, the thermal conductivity of the balloon rubber has the thermal conductivity with the 0.16 W over meter per Kelvin. So the first one is balloon without the water, which is it is filled with the air, has the thermal conductivity of 0.025 W over watt per meter times with Kelvin. So when the heat is applied to the balloon with the air, so it is obviously show that the balloon, the rubber, the K, the thermal conductivity of the rubber has higher thermal conductivity to the with the balloon without the water. So you have to note down that the heat transfer will be increased as the thermal conductivity increase. So it can be concluded that the balloon without the water will be burst first. Okay, so next we go to the balloon with the water. So for the balloon with the water, it is stated that it has the thermal conductivity of 0.6 watt per meter Kelvin. So for the balloon with the water, it has the 0.16 watt per meter Kelvin. So it is show that the thermal conductivity of balloon with water has higher than without
water.
Yes, okay. So so it can be concluded that when the heat is applied to the balloon, the water inside of the balloon will absorb the heat, so that it can withstand the heat. So the rubber itself will be not melt as the like the previous one. So the balloon will not burst.
I wanna get with you. You're so
Beautiful.
You're so beautiful.
Hey, Hidayah. Hi, Hidayah. What are you doing here?
I'm going to school.
Oh, okay. Hidayah, why you didn't iron your scarf? I just want to be honest that you look like quite hideous. Hasbi Rabbi Jalallah Ma fi qalbi ghairu.
Start.
Yeah, I have the chocolate and I want to eat this chocolate.
Hey, I want this.
My chocolate!
Mine.
My chocolate!
Mine.
This is mine!
I keep coming back.
No!
Hey,
It smells.
The truth is a stranger. Soul's in danger. Gotta let my spirit be free to admit that I'm wrong and then change.